Assalamualaikum students. I'm recording this video for you in which I will revise inshallah the end of term revision pack for statistics. Already I have recorded one video in which I solved all the questions which were given in the study list exam style questions. I hope you guys had already revised your exam style questions which can give you a very thorough revision on your final exam content and the study list. You got it? Now, this will also give you a very comprehensive go through with your study list content, the questions which I have posted in the review pack. Ready? So, Bismillah ar-Rahman ar-Rahim. First of all, you guys can see chapter number 5, probability distributions and discrete random variables. Question number 1. There is a discrete random variable x, which is describing the following probability distribution in the form of a table. So your random variable, discrete random variable, can assume 0, 1, 2, 3, and 4, and the corresponding probabilities are also given here. But you can see in the corresponding probabilities, some unknowns are seen, like in this case, you guys can see Q. If it is a discrete probability distribution, then we know that the sum of the probabilities is equal to 1. So what we need to do, guys, we need to establish an equation and put all these probabilities equals to 1. When we put them equal to 1, guys, we will solve this linear equation in Q, and this will give you the value of Q equals to 0.15, right? 0.26 plus Q plus 3Q plus 0.05 plus 0.09 equals to 1. When we solve it, it gives us Q is equal to 0.15. Next thing is we want to find the expected value. Expected value formula, we already know about it. That is equals to the random variable multiplied with the corresponding probability plus random variable 1 multiplied with Q. Its value is found by us in the first part, which is 0.15. Then 2 multiplied with 3 times 0.15. Then plus 3 times 0.05. Finally, the random variable 4 will be multiplied with 0.09. When we do all this thing, we will get the expected value equals to 1.56. Clear? Now we go to the next thing, which is called variance. Variance formula is already given in MF19, in which we know that we have to take the square of the random variable multiplied with the corresponding probability. So keep doing this. 1 squared multiplied with 0.15 plus 2 squared multiplied with 3 times 0.15 plus 3 squared multiplied with 0.05 plus 4 squared times 0.09. Then we have to write minus expected value, which is found earlier, 1.56, and we put a square on top. Then, guys, after computation of these numbers into the calculator, we find our final answer to the 3 significant figures, 1.41. And that's the final answer for the variance. So you can see sometimes in the exams, examiner gives you a table. The first thing which we need to notice in the table, if there a table of probabilities, if there is any unknown, then we have to create an equation summing up all the probabilities and put them equals to 1. And that gives you the value of the unknown. If there are 2 unknowns there, definitely we come up with another equation in those two unknowns. And finally, both equations will be solved simultaneously. Let's see, maybe in some other questions, we see those type of situations. Let's go to, guys, question number 2. In question number 2, we have a situation. In the previous case, probabilities were given. And the question number 2, a situation is given to us. 2 fair dice are thrown. 2 fair dice are thrown. Let X, the random variable, be the smaller of the two scores if the scores are different, or the score on one of the dice if the scores are same. The best thing to address this situation, make a two-way table. Since he's talking about 2 fair dice, I have to label horizontally 1, 2, 3, 4, 5, 6. And I have to label outcomes vertically for the other dice. Now, I need to look at 1 and 1. These are the same scores as per the statement. If you get the same score, you have to write one of them, one of the score, which is 1. Then 1 and 2, you have to take the smaller of them. So I'm going to write 1. 1, 3, 1, 1, 4, 1, 1, 5, 1, 1, 6, 1. Clear? 2, 1, 1, 2, 2, 2, then 2, 2, 2, 2. After that, 1, then 2, then 3, then 3, 3, 3, 1, 2, 3, 4, then 4, then 4. After that, for 5, 1, 2, 3, 4, 5, and 5, then 1, 2, 3, 4, 5, and 6. I want to write the probability of 1. So how many ones I have, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And in total, how many outcomes I have? 6 here and 6 here. So 6 times 6 give you total 36 outcomes. So total 36 outcomes I have. Now, out of these 36 outcomes, I need to see in the first column where how many ones I have. I have 11 ones. Now, can we count how many twos we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 twos. The probability of getting 2 is 9 over 36. In the same way, guys, you count how many threes we have. 1, 2, 3, 4, 5, 6, and 7. I'm writing here 7. In the same way, guys, count how many fours you have. 1, 2, 3, 4, 5s. Yes. Then how many fives? And then how many 6? 1. And the sum of the probabilities must be equals to 1. And we are absolutely right. What I'm telling you, you need to add all these probabilities and their sum should be equals to 1, which ensures that I'm talking about a discrete probability distribution. After doing this, he's asking you, what is the expected value? So expected value is, as usual, like in the previous case I did, I take the random variable and multiply it with the corresponding probability. 2 multiplied with 9 over 36. 3 multiplied with 7 over 36. 4 multiplied with 5 over 36. 5, 3 over 36. And then finally, 6 multiplied with 1 over 36. And this gives you the final answer for the expected value equals to 91 over 36, or you may write it in three significant figure form. Clear, boys? So this is done. Now we go to the question number 3. Wow. Again, we got a table. Didn't I tell you? You might see two unknowns. Wow. So this, the sum of the probabilities will give you an equation in two unknowns. So this will help me to create A plus B and send the 0.3 and 0.25 on the other side and subtract them from 1. Final equation in simplified form comes to me 0.45 equals to A plus B, like this. So this is my first equation. It seems I'm gonna get another equation in A and B, which finally I will solve simultaneously to get the values of A and B. I'm interested in how can I make another equation? Yes, the guy gave you the expected value. How to write the expected value? Expected value, boys, it is 1 times 0.3 plus 3 times A plus 5 times B plus 7 times 0.25, and he said it is equals to 4. Can I simplify it, boys? When you simplify it, you get 0.3 plus 3A plus 5B plus 7 times 0.25. 7 times 0.25 gives you 1.75. It is equals to 4. And let me send 0.3 and 1.75 on the other side and subtract it from 4. So 4 minus 0.3 minus 1.75, and it gives you the answer 1.95. Didn't I tell you that I am looking for the second equation in A and B variables? Now this helps me to use the calculator function which is telling me I am solving the two equations simultaneously. When you solve them simultaneously, boys, those students who have the calculators, they can use simultaneous way, but at least you need to show the method to the examiner because he has put method marks for the students to show. So I will make B as a subject and I write 0.45 minus A and substitute it here into the second equation. So 3A plus 5. In the place of B, I will write 0.45 minus A is equal to 1.95. When I solve this equation, guys, it gives me A is equals to 0.15. Now, after finding the value of A 0.15, substitute it back here to get the corresponding values of B. So 0.45 minus 0.15 will give you B is equals to 0.3. So we are done, guys. We wanted to find the value of A and the value of B, which satisfies the two conditions, one in the table, and the second one is the expected value is equals to 4. We found A and B. Now, guys, we go to the question number 4. He said a fair spinner has edges numbered 0, 1, 2, 2. Another fair spinner has edges numbered -1, 0, 1. Each spinner is spun. The number of the edge on which a spinner comes to rest is noted. A random variable is the sum of the numbers for the spinners. Again, I will go for what? I will go for the two-way table. So the score on the first spinner is 0, 1, 2, 2. And the second spinner, the scores are -1, 0, and 1. And I have to create a sum table. As you guys can see, 3 numbers are here, 3 numbers are here, and I'm expecting 9 outcomes in total. Can I add -1 and 0? I get -1, -1 and 1, 0, 1 and 1. Then 0 plus 0 is 0, 0 plus 1 is 1, 2 and 2, 1, 2, 3 and 3. Your X represents the sum values. So X can assume all the values which are seen here. Total 9 values will be seen. So my X can be, come on, my X can be -1 because it is one of the outcome. My X can be 0. It is one of them. 1, 2, and 3. So when I create a table, boys, I need to know their corresponding values. How many times -1 is appearing? Only one time out of, guys, sorry. There were 4 elements here. So 4 times 3 is 12, not 9. So now -1 is only one time appear. So I'm going to say the probability of -1 over 9 is 1 over 12. The probability, I'm writing here all the probabilities. So 0, 2 over 12. The probability of 1 is, there are 4 ones. Probability of 2 is 3 2s. The probability of 3 is 2 3s. So 2 plus 3, 5, 5 plus 4, 9, 9 plus 2, 11, 11 plus 1, 10. So this is the probability distribution for all the random variables, which are actually the possible scores when the 2 spinners are spun. Now in the B part, I want to find variance, and you all know variance cannot be found unless we find the expected value. So let's find expected value. EX is equals to -1 multiplied with 1 over 12 plus 0 multiplied with 2 over 12 plus 1 multiplied with 4 over 12 plus 2 multiplied with 3 over 12 plus 3 multiplied with 2 over 12. When you do this, guys, your expected value comes to you equals to 15 over 12. 15 over 12. So this is my expected value. And I'm going to use this expected value in the next formula, which is required, expect the variance. So what is the formula for the variance? You know, you have to take the square of the random variable multiplied with 1 over 12, square of the random variable multiplied with 2 over 12, square of the random variable and multiply with 4 over 12, square of the random variable multiply with 3 over 12, square of the random variable multiply with the corresponding probability 2 over 12, then write minus expected value 15 over 12 whole squared. And after calculating this big expression through the calculator, it gives us finally 65 over 48 or 1.35. 1.35 or 65 over 48. So this is my variance. So we are done with expected value. And then finally, we use that expected value to find the variance of the random variable. Next question. Examiner has talked about a pet shop which has 6 rabbits and 3 hamsters. So total 9 animals or total 9 pets you have. 5 of these pets are chosen. When you choose something, you know that always combinations come to my mind. The random variable represents the number of hamsters chosen. So 6 rabbits, 3 hamsters. So 5 of the pets are chosen X represents the number of hamsters chosen. What are the possible situations? Let's write. Can I write three hamsters and 2 rabbits? Their sum is equals to 5. Yes, this is one of the case. Can I say 2 hamsters and 3 rabbits? It is one of the case. 1 hamster, 4 rabbits goes to 5. It is the second case. And then finally 5 rabbits and no hamsters. The sum is also equal to 5. So may I say 3, 2, 1, 0 are the possible values of the random variable. So my X can assume these values. My X can be 0, can be 1, can be 2, and can be 3. Now in the first part, he said exactly 2 hamsters. So he's asking you, what is this probability? How many hamsters? Hold on. Before doing anything, I will look at the without restriction area denominator. The denominator is always telling you how many total pet animals you have, total 9 pet animals, and how many pet animals you are selecting, 5. So this is without restriction, which is a must. Without restriction, which is a must to be written in the denominator. On the top, what do you want? 2 hamsters. So I will write 2 C's, 1 C for the rabbit. Total rabbits are 6 and total hamsters are 3. And he said I need to pick 2 hamsters. If you pick 2 hamsters to make the total of 5, 3 rabbits I have to choose. So this will give you guys the final answer equals to 60 over 126 or 10 over 21. 10 over 21, which is already given by the examiner. Now we need to find the other probability. So I'm going to write X is equals to 0, 1, 2, and 3. And here underneath, I will write their corresponding probabilities. So for 0, I have to write what? 9, C5. How many rabbits? I don't know. 6 rabbits total. Hamsters 3. You want to pick no hamster. So no hamster. How many rabbits? Definitely 5 rabbits. This is the first case. Second one, 9C5, rabbit 6, hamsters 3. I want to pick 1 hamster and 4 rabbits. This probability I have already found, which is 10 over 21. For 3, 9C5 without restriction, total in the denominator, and in the numerator, I will write 6 for the rabbits, 3 for the hamsters. So from the hamsters, I'm going to pick 3 hamsters and 2 rabbits. So this gives you the probability, guys, equals to 6 over 126. And this gives you 45 over 126. Can I make it as over 26? So it will become 45 over 126. Now 60 over 126, sorry. It is 60. And he multiplies with 6 up and down to make all the denominators 126. It looks good. Otherwise, no need if you don't want to make the denominator 126. We already found it. The next one is when we do calculations, it will give us 15 over 126. Since the denominators are same, 126, 126, 126, can we add our numerators? The sum will come equals to 1. It means our calculation is 110% correct. So we found the corresponding probabilities. We defined the random variable, which was representing the number of hamsters. Now, alhamdulillah, guys, we are done with our revision of discrete probability distributions. Now we move to the next chapter, which is permutations and combinations. Question number 1, he says that in how many ways 5 people can sit in a row of 5 chairs? So you have 5 people, 1, 2, 3, 4, 5. So there are 5 people, and we want to arrange these 5 people who are sitting on these 5 chairs. So 5 people, 1, 2, 3, 4, 5. If you have 5 people and you want to shuffle those 5 people, in how many ways we can do that? We can do it in 5 factorial ways directly. But if a student says, no, Mr. Omar, can you give me how 5 factorial you wrote it? I said, out of the 5 peoples, we call them to fill the place number 1. So there are 5 ways to fill the place number 1. After making one person sit at the chair number 1, 4 left. So there are 4 ways to fill the chair number 2. Then after filling the second place, making anyone sit over there, now 3 people are left, and we ask the 3 peoples to fill the third chair, and in how many ways they can fill this? In 3 ways. In the same way, 2 ways the 4th chair, and the 5th chair can be done in 1 ways. And you know 5 times 4 times 3 times 2 times 1, it is equals to 5 factorial. Why not directly? I can say if I have 5 people and I want to arrange all the 5 people in a straight line, so the number of arrangements for them is 5 factorial. Or if you want to write it in P form, you can say, Mr. Romer, this is 5P5. So 5P5 is basically 5 factorial. Let's go with the B part. A race has 4 runners. In how many orders they can finish if they all finish at different times? So 4 runners, and there is an order. Permutation is related with order. Arrangement is always related to orders. First rank, second rank, third position, fourth position. So first, second, fourth, third and fourth. So 4 people. In how many ways we can order them? Definitely we can do it in 4 factorial ways. No need to waste time in furthermore explanation. We have 4 peoples and we want to arrange them in different orders. So we can do it in 4 factorial ways. Let's go to the C part, in which he gave you a word Cambridge. CAMBRIDGE. Interesting thing, in Cambridge, none of the letter is repeated. So how many total letters we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 letters in the word Cambridge. In how many ways we can arrange these letters in these 9 places? Definitely a student can say, Mr. Romer, the first one can be done in 9 ways, the other one in 8 ways, then 7, then 6, then 5, then 4, then 3, then 2, then 1. In the counting principle, we need to multiply them. Mr. Romer, the answer is 9 factorial. Yes, I was telling you it has to be 9 factorial, or you can also call it as 9P9. Because in Cambridge, none of the letter is repeated. All letters are different, and I want to arrange it, not selection, arrangement. So arrangement is permutation. So simply, I will say 9 factorial ways we can arrange these letters. Next question. There are 6 people, including husband and a wife, and a row of 6 chairs, in how many ways they can sit if husband and wife to sit together and not to sit together. Um, in the first part, I want to make them sit together. So I will call husband and wife first. I say husband and wife. On their chairs, because they are sitting together, on their chairs, they can be shuffled in 2 ways, husband, wife, wife, husband. So in how many ways it can be done, guys? In 2 factorial ways, husband and wife can be shuffled. But now externally speaking, it will be considered as only one chair for me because wherever husband goes, wife will also go with him. Now, how many other chairs left? Any other people are left? 4 people are left. Now we have 4 people left. As I said, I have to make 4 more boxes. Can I label them? This is the second box, third, fourth, and fifth. So total, there are 5 boxes. Now I'm not looking into the yellow region. That has been already concluded by us, which is 2 factorial. Now 5 boxes you have, and I want to shuffle them. In how many ways I can arrange them? As from the previous questions we experienced, we can do this job in 5 factorial ways. Wow. So this can be done in 5 factorial ways. So in total, 5 factorial times the 2 factorial, we have to multiply them. By counting principle, you keep on multiplying the probabilities. So as I said, I considered this one as 1, 2, 3, 4, 5. So this is 5 factorial, and the yellow one was 2 factorial. So 5 factorial times 2 factorial gives you guys equals to 240. Next question, I want to make the husband and wife not to sit together. So how can I do this? I think the easier way is this. I will use the complement way. The complement way is I say that in how many ways the husband and wife can sit together? 240 ways. If all of them are sitting without restriction, if all of them are sitting without restriction, any husband and wife can sit anywhere. In how many ways? There are total 6 chairs I have. 1, 2, 3, 4, 5, and 6. I said, guys, go and sit anywhere. And how many ways they can do that without restriction? 6 factorial ways. Now, from this 6 factorial without restriction, you need to subtract 240. Now, once you subtract 240 from 6 factorial, the complement of together sitting is not together sitting. The complement. So complement tells you that 240 should be subtracted from the non-restricted situation. This is no restriction. And they are together. And the final answer, which will come to me, is 480. It tells me they are husband and wife are separated. Question number 3. 8 books are to be arranged on a bookshelf. 8 books. 3 of the books are by the same author. In how many ways the books can be arranged on the bookshelf if the books by the same author are to stay together? Now there are 3 books. Book number 1, book number 2, and book number 3. These 3 books are written by the same author. Yeah. In how many ways we can shuffle these books? in 3 factorial ways. Now, I will be considering this box as 1 for me. How many others? 5 more books, which can come anywhere. He didn't put any restriction on those other 5 books. So let me say, externally speaking, how many boxes I have? 3, 4, 5, and 6. So I'm going to consider this one. This is 2. This is 3. This is 4, 5, and 6. In how many ways I can shuffle these books? I can shuffle them in 6 factorial and times with 3 factorial, because as per counting principle, we need to multiply. Externally, 6 factorial. And internally, one of the box can be done in 3 factorial. The total answer is 4,320. Let's go to the question number 4. How many ways can the letters of the word Nepal, N, E, P, A, L, so that not a vowel at either end? So these are the 2 places. How many vowels we have? We have 2 vowels, E and A. So these are the 2 places where the vowels can come. In how many ways we can fill them up? In 2 ways. I can say that 2p2 because I have 2 places, the starter and the ending. This can be done in 2 factorial ways or 2p2 ways, because this E and A, and I can write E first and then A, or A first and then E. You got my point, guys? So there are 2 ways that the vowels can come. Yeah. So this is two factorial ways. Now, how many letters in between left? 1, 2, and 3. So they can be done in how many ways? In 3 factorial ways, because we can shuffle them internally in how many ways? 3 factorial ways. So, boys, as you see, he said that how many ways can the letters of the word Nepal be arranged so there is not a vowel at either end? But I did it. A vowel is at the end. A vowel is at the end. I'm doing it in a different way. The question is not like this. The question says, vowel must not be seen at the end. How to do this now? I have 3 consonants, NPL. There are 3 consonants, and I want to use them at either ends. So 3 letters and 2 places. In how many ways we can do that? I will call it as 3p2 ways, because N, P, and L can come at these 2 places. I can write the possible cases for you. For example, Mr. Omer is writing N and L here. This is 1. N and P here. This is 2. Is it clear? I can write P and N here. P and L here. L and P here. L and N here. So did you count? There are 6. So 3p2 will give you the 6. So in permutations, if you have 3 things and you want to use them, use only 2. In how many ways you can arrange the 2 letters out of the 3? So there is a 3p2 ways. Done? Now you have in between how many letters? There are 3 places, and you have 3 letters with you. So 3 letters which can come in anywhere. In how many ways we can shuffle them, guys? 3 things and 3 places, 3 factorial ways. So we can shuffle them in 3 factorial ways. I hope it is clear to all of you that 3p2, why I wrote it here, because I was having 3 letters and I have to fill the 2 yellow spaces. So this can be done in 3p2 ways. However, in between there are 3 letters. They can come in any order, which can be done in 3 factorial ways. The final answer comes to me equals to 36. Question number 5. Now, this is a past paper question. Find the number of arrangement of 9 letters in the word alligator. Wow. In alligator, there is one thing interesting. The interesting thing is L is repeated 2 times. The letter L is repeated 2 times. And the letter A is also repeating 2 times. So 2 A's, 2 L's, and 1 others. Clear? In how many ways we can do that? Count total letters are 9. If all of them are different, we can do it 9 factorial ways. But we have 2 A's, so 2 factorial for 2 A's times 2 factorial for the 2 L's. So this 2a factorial is written for 2 A's. And this 2 factorial is written for 2 L's. And 9 factorial is basically for all of them are 9 divided by 2 factorial and 2 factorials. So we get our final answer equals to 5040. 5040. Let me get my final answer. And I need to check from my calculator as well. 9 factorial divided by 2 factorial. All right, 2 factorial. So we get our answer 90720. So let's see, is this the thing which is required? No, he is not saying that simple question. He said that the 2 A's are together. Oh. If the question was simple in which I wanted to make the alligator, I wanted to use all the 9 letters, so that was the right way of solving this question. Now he has put some restriction. So what are the restrictions, guys? He has made it. Let me keep the 2 A's, 2 L's, and 1 others. He said that A's are together. I'm going to make a box for A's. Internally, they cannot be done in 2 factorial, just one way. I'm going to consider it as 1. 2 L's, I'm going to consider them as 1. So this is my second. How many others? 5 others. So total 7 factorial. They are the same, so I can do it in 2 factorial divided by 2 factorial, which is 1. They are the same in how many ways they can be shuffled in 2 factorial divided by 2 factorial is equal to 1. So times 1 times 1, basically 7 factorial, which is 5040. The previous thing which I did it, that was like a 1 mark question normally comes when I have a 9-letter word and I want to arrange it without restriction. So 9 factorial divided by 2 factorial times 2 factorial. But this is a restricted question in which he puts restriction on us that A's must be together, which can be done in one way. L's must be together and considered as one. It is one way. Externally, my friends, this is considered as one. This is considered at 2, 3, 4, 5, 6, and 7. That's why I wrote 7 factorial. And my final answer came to you 5040. Yes, question number 6. The thing which I was trying to do, now he has asked you. The word Oxford, you can see O is repeating how many times? 2 times. Total 5 letters. In how many ways I can arrange it? Definitely 5 factorial, but I have to divide with 2 factorial since I have 2 O's. B part. Do we have 5 letters? No, the total 6 letters. Sorry, guys. The final answer comes to us 360s. Then I have MISI, Mississippi. How many S I have? 1, 2, 3, 4. How many I's I have? 1, 2, 3, 4. How many P's I have? 2 P's. Total, can I count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 factorial. If all of them are different, then I can arrange them in an 11 factorial. But I have to divide with the repeated number of letters. So I is repeated how many times? 4. So I will write 4 factorial. How many times S repeated? 4 times. So I will write 4 factorial. How many times P's are repeating? So 2 factorial. So this will give you the final answer. 34,650. Now we reach to the question number 7. A committee of 5 people is to be chosen from 4 men and 6 women. Total people are 10, and you want to pick 5 people from them to make a committee. William is one of the 4 men. And Mary is one of the 6 women. So William is among those 4 men, and Mary is among those 6 women. What is the number of different committees can be chosen if William and Mary refuse to be on the committee together? So how can we solve this type of a question if William and Mary refuse to be on the committee together? Can we make William and Mary in the same committee and look into this question in complement way? You get my point. The opposite of William and Mary together in a committee is I can write the cases for you. William, Mary, both are in the committee. Not William, but Mary. William, but not Mary. Not William, not Mary. Believe me, guys, if you find this probability, William and Mary both are in the committee, then I subtract it from the total. That gives me that William and Mary refuse to come in a committee. So this is the case which examiner is looking at. So I assume I have selected William and Mary. So 2C2 means there are 2 people, William and Mary, you have selected. So I wrote 2C2. What does it mean? That among the 5 people of a committee, the William and Mary are selected. How many left? Total 10 people. So 2 William and Mary are put on the side. 8 left. So I want to make a total of 5 people. So that's why I will pick 3 people from others to make the total of 5. So 2C2 tells you what? William and Mary are selected. And 8C3 is like the other people, combination of women and men. And I'm picking 3 from them. But I compulsify that William and Mary in yellow region, they are selected. Both are selected. So what is the probability I have found it? So let me find 8C3, which comes to me, guys, equals to 56. Now without restriction, without restriction means the total. Total people are 10, and I'm picking 5 from them. In how many ways we can do that? 252. Now I am ready to use the complement way to get my answer. So the final answer which you are looking for, I have to write 252 minus 56. So 56 is what? William and Mary are together. 252 is what? Without restriction. Okay, these are all the possible ways of finding, choosing 5 people from 10 people. The subtraction of 56 from 252, the answer 196 tells you these are those committees. These are 196. These are those committees in which maybe William is not there in that committee, or Mary is not there in that committee, or both William and Mary's are not there in those committees. The best way in the final exam is like if these type of questions come, you have to always look at the complement side. Yani, I don't want to keep the people. You say, no, I want to keep them in one committee. Okay, if you want to keep them, so you want to take them. So there are 2. You are picking all of the 2. How many remaining people you are left with? Total are 8 left, and I want to pick 3 from them because the total people I want to select in a committee, there are 3. So 2 are already selected. So you just write the remaining 3 for the 8 other people. Question number 8. A committee of 5 people is to be chosen from 7 men and 6 women. So 7 plus 6, guys, is how much? Total 13 people I have, and I want to pick 5 people from them. If there is no restriction, wallahi, guys, I'm going to write 13C5. But is he putting any restriction? Yes, he says that you have to take only those committees which have majority of men. So the best way of solving these type of questions, right? 7 men and 6 women. Majority, total 5 people. I'm going to write 3 and 2. Sum is 5. 4 and 1. 5 and 0. Write this case. 7C3 times 6C2. Second case, 7C4 times 6C1. Third case, 7C5 times 6C0. So the first answer comes to you 525. Second answer comes to you 210. Third answer comes to you 21, and we add them up. It gives you 756. That's the final answer. Question number 9. A committee of 5 people is to be chosen from 8 volunteers. From 8 volunteers, including a husband and a wife. How many different committees are possible which do not include husband and wife? Guys, it's the same type of a question which has been already discussed. Clear? How many volunteers you have? 8. Total people in a committee are 5. I will include husband and wife. Husband and wife both are included. How many left out of the 8 because 2 are put on the side? 6 people left. How many people are still left to find them in a committee of 5? 3. So this gives you 20. Now, can you please find without restriction? The totals. I have total 8 people and I want to select 5 from them. And this gives me 56. I want to get my answer, which is 56 minus 20. So 20 is representing together. Husband and wife are included. This is total without restriction. When you subtract them, I get my answer 36, which shows not together. Husband and wife. And my final answer is 36. Question number 10. He says, a committee of 5 is to be chosen from 8 volunteers, including a husband and a wife. If the committee members are chosen randomly, what is the probability that a committee includes both husband and wife? Wow, very good. We want to include both husband and wife. So 2C2, they are included. How many others left? 6 people left. Out of them, I need to pick 3. Is my job done? No, it's a probability question. I need to divide with the without restriction. So without restriction, in the denominator. Total people 8, and I'm picking 5. So 2C2 times 63 over 8C5, it gives us 5 over 40. That's the final answer. Now we go to the question number 11. A committee of 6 people is to be chosen from 9 women and 5 men. There are 6 people in a committee. Find the number of ways in the 6 people there must be more women than men in the committee. I'm going to write here 9 women and 5 men. More women. So may I write 60 guys? 51, 4, 2. Can I write 3? No, 3 is not possible. So just 4 cases. So this gives you 9C6 times 5C0. Second case, 9C5 times 5C1. Third case, 9C4 times 5C2. So the first answer is 84. Second answer is 630. And the third answer is 1260. We need to add all of them. And this gives you 1974 is my final answer. The 9 women and 5 men include brother and sister. Find the number of ways in which the committee can be chosen if sister and brother cannot be both on a committee. So guys, can we put brother and sister in a committee? So there are two. I'm going to include them, brother and sister. Brother and sister. I'm doing this question with a complement way. So brother and sister are included. How many others are left? Total, you remember we had 9 plus 5, 14 people. So now 12 people are left with me. Yeah. So 12. So 6 people I wanted to select. So 4 people are here because in the beginning he said like he wants to pick 6 people. So 4 others are left. Right? So find the number of ways in which the committee can be chosen as a brother and they cannot be brother and sister cannot be both on a committee. So both are selected. Let me find my answer. 12C 4 gives me let me get my answer. 12C4 it gives me 495. Without restriction, is total people are 14 and I want to pick 6 from them. So 14C6 gives you 3003. Answer will be equals to 3003 minus 495. This represents total. This represents what? Brother and sister. And when I subtract them, 2508, this is telling you not brother and not sister. So they are not together. So they are not in the committee. Brother, sister, not together. Our final answer is 2508. Question number 12. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women. It must include 3 men and 3 women. 6 men, 8 women, and I want to pick 3 men and 3 women. Very simple. 6C3, 8C3, and the answer is 1120. A different committee of 6 people is to be chosen from 6 men and 8 women, and 3 of the 6 men are brothers. Find the number of ways in which this committee can be chosen if there are no restriction on the number of men and women, but it must include no more than 1. So no more than 2 of the brothers means what? This is important, guys. When I say that no more than 1, so it no more than 2. Sorry. What is this? No more than 1. 0 brothers, 1 brother, 2 brothers. So he's asking you 3 cases for 0 brothers. If you have 0 brother, from the 3 brothers, you are not going to select anyone. And from the other people from these 3 brothers, total 14 minus 3 is 11. I want to pick 6 people, so 11C6. If I want to pick 1 brother, so 11C5. If I want to pick 2 brothers, then from the remaining 11, I'm going to pick 4. This answer is 462. This answer is 1,386, and this is 990. We need to add all of them, and that gives you the final answer, 2838. Alhamdulillah, now the permutation combination chapter finished. We move to the binomial probability distribution. The first case, very simple. He gave you the number of trials and the probability of success. I can write from my side the probability of failure, which is 1 minus 0.2 is 0.8. And I want to find for the random variable x is equals to 3. Very simple. Total number of trials, 12. I'm interested in 3. Failure, first of all, which is 0.8 raised to the power subtraction of 12 minus 3. So 12 minus 3, and success 0.2 raised to the power, whatever I see down here, how many successes we have? 3. That gives me the final answer, 0.236 to the 3 significant figures. Next. In the next case, number of trials are 10. Probability of success is 0.9. May I find the probability of failure? 1 minus 0.9, which is 0.1. I am interested in x less than equal to 8, which shows x is equals to 0. Oh, there are so many cases. Shall we look at the complement? Obviously, we should look at the complement because we are going to get so many cases under x less than equal to 8. So the complement of x less than equal to 8 is 1 minus probability of x greater than 8. And in greater than 8, I'm going to write x is equals to 9, x is equals to 10. So there are 2 cases which we need to add. So total trials are 10. I'm picking 9, failure 0.1 raised to power 1, success 0.9 raised to power 9, plus 10C10, failure 0.1 raised to the power 0, and 0.9 raised to power 10 successes. And that gives us the final answer, 0.264. 3 significant figures. Next, I want to find the mean and the variance of binomial probability distribution. In MF19, the formula for the mean and variance of binomial distribution is given. Let me write it again. The mean formula, it is NP, and the variance is equals to NPQ. So don't forget that. So the guy gave you number of trials 10, the probability of success is 0.2, and the failure is 1 minus 0.2. It will give me 0.8. So can I find NP, which is equals to mean, N is 10 times 0.2. So that gives you guys 2. The mean is 2. And NPQ, variance, which is NPQ, so 10 times 0.2 times 0.8. So the final answer is 1.6. Now we go to the question number 4. So question number 4 says, in a certain large college, 22% of the students own a car. 22% students own a car. So it looks like that this question can be modeled as binomial probability distribution. And a student is your trial. How many students in the first case you have? 3 students. Probability of success is 0.2. 0.22. Probability of success is 0.22 because success for me is when I select a student, he owns a car. And the failure is he doesn't own the car. So the probability of failure is 0.78. Now, 3 students from the college are chosen at random. Find the probability that all the 3 students own a car. So I'm doing the first part. So 3 students, all the 3 students you are looking at. Failure, 0.78, 3 minus 3, 0, and 0.22 raised to power 3. So all the 3 people, the 3 students, you get a success. So I am actually looking at x is equals to 3. So this gives you the final answer, 0.0106. B part. Now, rather than 3 people, you have a new binomial probability distribution in which you have 16 people, but the probability of success stays the same. Yani 0.22 is your success and your failure is 0.78. Now, he says the probability that a number of these students who own a car is at least 4 and at most 4. So X is between 2 and 4 inclusively. It leaves behind 3 possible cases. X is equal to 2, X is equal to 3, and X is equals to 4. So for X is equal to 2, guys, 16C2, failure, 0.78 raised to power 14, and 0.22 raised to power 2. Second case, 16C3, failure, 0.72 raised to power 13, and 0.22 raised to the power 3. Last case for X is equal to 4, 16C4, 0.78, 16 minus 4 is 12, and 0.22 raised to power 4. And then the final answer will come to me 0.631 to the 3 significant figures. Question number 5, guys. Eggs are sold in a box of 20. And in each box, we have 10 eggs, 20 eggs. So n is equals to 20. Cracked eggs occur independently. When he says cracked eggs occur independently, it means that he is trying to idealize the binomial probability distribution, because in binomial probability distribution, we already said that every trial must be independent from the other trial. Did he give us the probability of a cracked egg? No, he didn't tell you, but he gave you the mean number of eggs which are cracked. It is 1.4. So I have to find the probability of success. How? Mean formula, it is equals to NP. He said mean is 1.4 and n is 20. We can easily solve this equation and get the value of P. The value of P gives you 0.07, and you can also write the Q 0.93. Now, exactly 2 cracked eggs. So X represents number of cracked eggs. So probability of X is equal to 2. Easy. Total eggs in a box, 20. Is it? Yeah. And you want to look for 2 cracked eggs. Failure, 0.93 raised to the power 18, 0.07 raised to power 2. So that gives you the answer 0.252, 3 significant figures. Part 2. Find the probability a randomly chosen box contains at least 1 cracked egg, at least 1. So probability X greater than equal to 1. Why is X greater than equal to 1 means X is equals to 1 x is equals to 2, so on and so forth till x is equal to 20. It leaves behind so many cases. Can we look at the complement? Yes, we need to look at the complement of these cases. The complement of these cases must be probability of x is equals to 0. And then 1 minus 20C0, failure 0.93 raised to the power 20, and success 0.7 raised to the power 0. And then the final answer after this will be giving you 0.7663 significant figures. Yes, question number 6, sorry. State 3 conditions for the binomial distribution. Number 1, we have finite number of trials. So there are finite number of trials. N should be finite. It shouldn't be infinite or infinite. Second condition, every trial must have 2 outcomes. First outcome, it is called success, and the second outcome will be called failure. Third, probability of success is constant. It shouldn't be changed in every trial. And the fourth one is, I'm writing one more for you. Every trial must be independent. Every trial must be independent from the other trials. Okay? George wants to invest some of its monthly salary. He invests a certain amount of his every month for 18 months, and he is investing. Each one, there is a probability that 0.25 he will buy shares in a large company. There is a probability that 0.15 he buys shares in a small company. There is a probability that 0.6 he will invest in a saving account. So there are 3 categories we have. We have large company, we have small company, and saving account. Large company probability is 0.25. Small company 0.15. And he buys shares, again, he will invest into the saving account for 0.6. Find the probability that George will buy shares in a small company. So small company is my success. Small company is my success, and my failure would be 0.85. Number of months are 18. He said at least 3 of the 18 months. So x greater than equals to 3. This is required. If I write all the possible cases, there will be so many. So I'm going to go for complement. So this is basically x less than equals to 2. So 1 minus x is equals to 0, x is equals to 1, x is equals to 2. 1 minus 18C0, failure 0.85 raised to the power 18, success 0.15 raised to the power 0. For x is equals to 1, 18C1, 0.85 raised to the power 17, 0.15 raised to the power 1. Next, the last one, 18C2, 0.85 raised to the power 16, and 0.15 raised by 2. And then finally, guys, I'm going to get my answer. 0.520 to the 3 significant numbers. Finally, I am done. So guys, I have recorded this video for you, the complete solutions of the revision pack for the statistics exam, which inshallah you will sit for on Tuesday. If there will be any confusion, misunderstanding, or you want to clear your concepts further, please talk to me and send messages, and then inshallah I will explain you further. But in my understanding, the explanation which I have made it over here, that is very rigor, and everyone can easily solve all types of questions related to the 3 chapters which are planned for your final exams. Thank you guys. Assalamu alaikum wa rahmatullahi wa barakatuh.